NCBM 0324, Section 1.3, Slope Formula and Graphing Linear Equations in Slope-Intercept Form, Part 2. So we're looking at slope to start us off. Remember that slope is rise over run. Depending on the sign of our rise and the sign of our run, we're either going to move up or down, or left and right, So let's look at example B. Again, we're finding these slopes graphically and algebraically. So graphically first. So by the graph, we are going to look for two ordered pairs, 2 points on our graph that we can use to make our measurement. So looking at my graph now, it's down here. Again, it's a straight line. There's no curve to it, so it's linear. I'm looking for 2 points that are easily measurable, or you can count the values to the other one easily. And I'm liking this along my y-axis, and just to write my ordered pair, that looks to be 0, -6, just so we have that information for later. And I need a second point, so I'm going to look, maybe I'll go, I don't know, maybe up here. That looks pretty right on the crosshairs of my grid here, my Cartesian plane. So let's see about the ordered pairs for that point. That looks to be -6 in the x direction and -3 in the y direction. Okay, so we have our ordered pairs. We'll use those in the next step, but let's count for now. So I'm going to have to count the rise and the run. If I'm going from this point, the 0, -6, to my other point, I'm going to count the rise first because it'll be my numerator. In this case, I'm going to go up because I'm going in this direction here. So it looks to be 1, 2, 3. So my rise is going to be 3 up. Then let's count the run. So that's the left and right. It looks like I'm going to have to move left. 1, 2, 3, 4, 5, 6. So my run is 6 left. And let's write that out as slope. So slope is rise over run. In this case, that's going to be 3 over -6, because I move left. Remember, left is negative. So I have 3 divided by -6. Well, I can reduce that fraction down because 3 goes into 6 2 times. And then I can write the negative in this way here. So it looks like our slope is -1/2. Now, something to note about that negative sign, there's really 3 places we can write it. That negative can be written at the bottom. So we could have 1 over -2 if we wanted to. We can write it on top, or we can write it completely in front of the fraction. All these 3 mean the exact same thing. We just traditionally and more commonly we see that negative kind of up top in that fraction form. But it looks to be like our slope is -1/2. Let's try this with the formula. So algebraically. So formula, in case we need it, so our slope is equal to that y2 minus y1, all divided by x2 minus x1. Just to have my ordered pairs written out down here, let's go ahead and even label them. And I'll have my x1, y1, x2, y2. So I can plug them into my formula easily. I will say slope. My y2, that's a -3. Notice anytime I have a negative, I'm going to use parentheses to keep track of that sign. I don't want to lose it. So that's the y2 minus y1. So minus is the formula. The y value is negative. So it's going to be a double negative there. All right, let's go to the x's on the bottom. x2, that's negative 6, minus x1, we said was 0. So then I will have my slope. Let's check the top. Okay, we have negative 3 minus negative 6. Well, the negative and the negative turn positive on the 6 here. Negative 3 plus 6 is a 3. And the denominator, negative 6 minus 0, is negative 6. Notice, that's the same measurements we made with the rise and the run. And we said that reduces down to negative 1/2. So our slopes turn out to be the same. Let's see two more. Same thing, graphically and algebraically, we're finding the slope. So for part C, we have this kind of unusual line, slightly different than the last two we saw, but it's still linear, still a straight line here. And again, we're going to do this by the graph. I'm just going to abbreviate now. Graphically, algebraically. Those are my abbreviations. So graphically, I'm going to have to calculate the rise and the run. So let's pick some points. I'm going to go ahead and stick with the same value there along my y-axis. That looks to be 0, negative 1. And if I pick a second point, I don't know, maybe over here. Let's see what that ordered pair is. That looks to be 8, negative 1. Let's find the slope in the rise over run version. So let's calculate the rise. So from one point to the other, this will be my first point, this will be my second point. How far up am I going to get to this point over here? Well, it doesn't look like I'm going up at all. So it seems like my slope, the rise part, is going to be 0 because there is no rise to it. There's no up or down movement to get from one point to the other. Let's check the run. Do I have a run in this example here? Well, it looks to be 1, 2, 3, 4, 5, 6, 7, 8. Right, our run is 8 to the right. So that's a positive 8. So then I have 8 on the bottom. But what is 0 divided by 8? If I check that in the calculator, it's going to give me 0. Right? So in reality, it didn't matter that I picked this 8, negative 1 as my ordered pair. I could have picked something over here, maybe even something in those middle areas that we were avoiding earlier. But what's unique about all of these points on this line, the rise is always 0, right? There is no up or down movement to move along the points on this line. That's pretty unique, I think. Let's see if this works out with the formula. So here's my slope formula. Let's put the ordered pairs down. Label them. And let's fill in to the formula. And let's see. So my slope is going to equal to y2 minus y1. Again, there's negatives here, so putting those in parentheses so I keep track. There's a minus from the formula and a negative from the value. Then on the bottom, I have 8 minus 0. All right, up top, my negative turns positive. And then I have negative 1 plus 1. Negative 1 plus 1, well, that's 0. And then on the denominator, 8 minus 0 is 8. So once again, 8 divided by 0 is still 0. And they match, as they should. So we've seen quite a few scenarios. We've seen where a slope can be positive, right? It's going up to the right when it's positive. We've seen a slope when it's negative. You see how it's going downward. Then we even saw a slope that's 0, and that's just this straight line. We're going to end up calling it a horizontal line, but it's pretty unique because of that lack of a rise. There's no rise, so that slope is 0. But what happens in this last case? Let's look at part D. So now my line is going straight up and down. Well, graphically, it's going to work the same way. So graphically, let's find the rise over the run. Rise over run. Let's pick 2 points. In this case, I'm going to pick this point, and that looks to be -3, 0. And maybe I'll pick a point, I don't know, right here. Just a random point on the line, though. It has to still be on the line. And that looks to be -3, 4. So if I'm counting the rise and the run, my rise, how do I go from this? We'll count the -3, 1 as our first point. How do I go from our first point to our second? Well, I'm going to rise 1, 2, 3, 4. So rise 4 units up. So that means it's a positive. So I'm going to say over here, slope is equal to 4. And then do I have any run? Is there any left or right movement to get from this first point to the second point? Well, there's no run, right? The run is 0. And what did we say in our earlier section about dividing by 0? Can we ever divide by 0? We cannot, right? That's a big deal in math. We can never divide by 0. So in this case, we're going to say our slope, the slope, is undefined. It's not possible. It's not a value that we can write down, right? It's this undefined, this unknown part. Now, what is that going to look like in the formula? So algebraically, let's see what happens there. So my ordered pair that we picked, maybe you picked different values and that's okay. Try it out on your ordered pairs if you did. Labeling. Maybe at this point you're good without the label. We're going to say our slope is equal to, let's check our y values. Those go on top. y2 minus y1, that's 4 minus 0. x2 minus x1, that's my denominator, so x2 is -3. Minus x1 is another -3. All right, so in the top, 4 minus 0 is 4. On the bottom, we have another negative situation, so that turns to plus. -3 plus 3 gives me 0. So once again, our slope is undefined. And in fact, those are the 4 cases. If we're talking slope, it's going to be one of these 4 possibilities. Either our slope will be positive, it'll go upwards, if you're looking at it from left to right. Our slope will be negative, it'll go downwards if we're going left to right. Or it'll be 0, meaning there is no slope, right? The 0 slope means that there's no up or down movement. In the last scenario, if it's a vertical line, the slope will be undefined. There's no possible calculation of slope in the vertical situation.